Alright, welcome back to the Green Ninja Climate Science series. In this video, we're going to be talking about is the Earth getting warmer? So it's kind of implied by the term global warming that the Earth is getting warmer, but let's look at what the actual evidence is for the Earth receiving an increase in temperature. So kind of the first most obvious place to look when you're trying to figure out if the Earth is getting warmer or not, is you can look at these meteorological stations that are on the surface of the Earth. And so these have increased in coverage over time, but scientists use various statistical techniques to stitch together records of the temperature from meteorological stations over periods of time and account for different spatial coverages and come up with kind of a single record. And so that is what this record is here, showing each year is a square here, and this is the global surface temperature of the Earth as recorded by these meteorological stations. So we see that since about 1880 up to 2012, there's wiggles in temperature, but overall there's been a large increase in temperature as measured from these meteorological stations. So an increase of about 1.2 degrees Celsius or around 2 degrees Fahrenheit, which is a pretty substantial increase in temperature relative to the geological record, which we'll talk about in a later video. But okay, so we can look at increases in temperature from meteorological stations. What else can we look at? Well, we can look at weather balloons. So since the 1950s, we've had weather balloons go up on pretty much a daily basis. And when you compare the temperature measurements, kind of globally averaged from weather balloons, that's the red line here, to the temperature measurements from meteorological stations, that's the black line, we have very good agreement from the 50s through the 2000s. So weather balloons are also showing an increase in temperature. Another measurement of temperature comes from satellites. So since the late 1970s, we've had satellites measuring temperature, and they essentially show that the increase in temperature has been roughly the same as what their weather balloons and what the meteorological stations show. So this gives us pretty good confidence that indeed the temperature has been warming pretty significantly, at least over the past few decades when we've had satellites, but then going back further using meteorological stations as well. So instead of modern technology to actually record the temperature directly, we can also look at indirect measurements of temperature. And one obvious place to start to look for indirect measurements of temperature is to look at how Earth's frozen water has changed over time, or the Earth's cryosphere. So there's frozen water in mountains called glaciers, there's frozen ground, there's snow, there's sea ice or ice just sitting on top of the ocean, there's ice sheets, giant masses of ice that sit on top of land. So we can look at how all these things are changing and see if we can infer any type of temperature change from them. So the first example here would be to look at glaciers. So there are some dramatic photographs showing large decreases in glacier extent. So in this case, we have a glacier in Glacier Bay National Park from 1941 to 2004, showing a pretty dramatic decrease in the size of that glacier. And here's another example of a glacier in the South Cascades from 1928 to 2000, so another decrease that's pretty visible. And so when we look at glaciers worldwide, we see a similar story. So this is the glacier, the length of these glaciers relative to their length in 1950 in different regions of the world. And we see a very similar story around the world that, since the mid-1800s, we've seen a large decrease in the length of these glaciers, which can be inferred to be coming from an increase in temperature. Other pieces of evidence, you can look at sea ice. So this is Arctic sea ice in September 1st, 1979. This is near the time of year when the sea ice is at a minimum in the Arctic, versus September 1st, 2012. and we see that this is from the first year of the satellite record to the most recent year of the satellite record. And we can see that during this time period, when satellites have been viewing the extent of sea ice, we've seen a very dramatic decrease in the amount of sea ice in the Arctic. And the Antarctic sea ice has actually been increasing slightly due to some mechanisms that we don't have time to go into here. But if you average them together, if you take the Arctic and the Antarctic sea ice, and you come up with a global data set of sea ice, we see that globally sea ice is decreasing over the time period that we've been able to measure it from satellites. So sea ice is decreasing. We can look at the mass of ice sheets. So Greenland and Antarctica are our two major ice sheets on Earth today. Since around 2002, we've had the GRACE satellite in orbit, which actually measures the gravitational pull of both of these ice sheets and is able to come up with a measure of how much ice is contained in these ice sheets from that gravitational pull. So we see that since 2002, when this satellite has been up, the Antarctic ice sheet has lost around, say, 1,200 gigatons of ice. To give you an idea of how big a gigaton is, 1 gigaton ice cube would look like this compared to the Empire State Building here. So a gigaton of ice is a lot of ice, and Antarctica is down about 1,200 gigatons just since 2002. And the other bad news is it looks like the rate of change is not linear but rather accelerating. So we can also use this same satellite to look at Greenland ice mass. And again, since 2002, we have a decrease of around 2,000 gigatons, so even more than Antarctica. And again, it looks like this rate of decrease is accelerating. So that's bad news because that water eventually flows into the ocean and we get sea level rise from that. Other pieces of evidence, we can look at the snow coverage in the northern hemisphere, where there's a bunch of land for snow to fall on. And since the 1960s in this data set, we've seen a decrease in the aerial extent of snow coverage. We can look at seasonally frozen ground. So again, this is extent in terms of area. And so we're down, looks like 3 million square kilometers in terms of frozen ground since the early 1900s. So all these things are kind of pointing in the same direction. We can look at the amount of time that different lakes and rivers are frozen over the course of the year. So here we have the date of freezing of different lakes and rivers, which were recorded back into the 1800s, and then also the date of thawing. And what you see is that in general, the freezing date is becoming later and later in the year, and the thawing date of these lakes and rivers is coming earlier and earlier every year. And so what that means is that the amount of time spent frozen is decreasing for all of these different bodies of water. We can look at the amount of total heat content in the ocean. This is from the 1960s, from a depth of 0 down to 2,000 meters, the total amount of heat, and we see that there's been a large increase in the total amount of heat in the ocean over that time period. That's measured from buoys, and now more recently we have floats that go around and measure the temperature and can calculate heat content from that. We have satellites measuring sea level with lasers that bounce off the surface, and you can come up with how far away the surface of the water is from the satellite and get a measure of sea level from that. So here's a graph of sea level going back to the 1870s or earlier, possibly. And so back then, it was really tide gauges that were used to come up with these sea level estimates, and then more recently, it's the satellite data. But we see overall a pretty steady increase in sea level over that time period, which again is due to the fact that ice sheets are melting and pouring water into the ocean. But it's also due to the effect that when water warms up, it actually expands. So we expect sea level to rise both because of melting ice from land as well as from just the thermal expansion of the ocean itself. So we have tons of different pieces of evidence kind of all pointing in the same direction that indeed, yes, the Earth is getting warmer. And there's really not very much controversy about that at all. I mean, there's just almost no way for all these things to be giving you the exact same answer without the Earth actually experiencing a very large increase in its temperature and heat content. So the Earth is definitely getting warmer.